looking at this problem, if I need my derivative, what am I going to have to do first? Quotient rule. We have things being divided. Okay. Write neatly. This is when sloppy handwriting is really going to start coming back to bite you.
Well,
Oh no.
well, you were looking back here, weren't you?
I very clearly looked at the board as I was saying that.
She did not want us to think she was looking at any one person.
Okay. So quotient rule. Low D high. So derivative of the top. We bring down the 3. We have the 1 minus x squared. Subtract 1 from the power, so it's squared. Times derivative of the inside is negative 2x. So all of this is representing the derivative of the top. So D high minus high D low. So derivative of the bottom. 2 comes down. Inside stays the same. Subtract 1 from the power, so it's now to the first, times derivative of the inside, which is 5 plus 12x.
You're going so fast.
Wait. You're on autopilot.
I'm sorry.
Which is why she let me steal the best calls.
Exactly.
I'm
I
glad
did
it's on
think
audio.
this.
I see.
Okay, so we had the bottom times the derivative of the top. Minus top times
Wait,
the
you need
derivative
your
of the bottom.
bottom. Your bottom.
Over below
Oh, okay, never mind.
squared.
Did we not make that to the fourth?
I will in a second.
Oh, squared.
No, we
Squared.
cancel. Oh my god.
Squared is.
So, depending on like how your mind works, you might be able to start simplifying things. I'm trying to show my work so you know where I'm getting things. So I am going to first multiply my 3 and my negative 2x and make that a negative 6x in front of this term. In the second term, you could distribute different things. At the very least, pull that 2 to the front. Now, you could take the 2 times the 5 plus 12x, and that's fine. I don't care, but at the very least, if you don't do any other simplification, I prefer coefficients to be in the front of the term.
Would that become negative 10 minus 24x?
If you brought in, if you did that, you'd have to make this a plus. If you bring in the negative 2, then the sign becomes a plus.
But it doesn't go anywhere else. It just
Right.
goes to that. Okay. So it becomes a plus minus 10?
Yeah, if you put the negative 2 in.
I don't know if I got the right answer.
Okay, so now squared is to the 4th. When I look at this, I have the same thing showing up in every term. So we can cancel only one of them. So I could take out one of these and then that's 3 of them left on the bottom. So my derivative is negative 6x times the 4 plus 5x plus 6x squared. You could distribute the negative 6x there if you wanted. This is not the only way you can write your answer. This is just one option.
That felt like a marathon.
I don't know why it's so loud.
This is like
But
an
I It's like every time you pick it up, you're like.
This is like I'm trying to figure, just like
It's
my
on
head
your
hurts.
Chromebook.
It's like the negative,
Like, okay.
it's like 2
Move your Chromebook.
I could just have minus on the outside.
That's kind of fun.
Mhm.
That's so
Like
much.
this.
But if I distribute the negative, plus parenthesis negative 10 minus 24x parenthesis.
Yeah,
okay.
Lots of different equivalent forms.
Hey, what is this?
Let's do another one. Uh-huh.
Can we see if this one?
E to the power of sine of x. We have to take the natural log.
No,
Oh,
she didn't make a happy face, so.
I didn't make it happy.
Why can't we though?
Okay,
That's a real question.
we're doing a derivative.
Oh, that's
Sine
why.
x.
That would make sense.
What?
Okay, just slow down and think about our derivative rule. What is the derivative of e to the power, to a power?
E to that power.
Oh,
that doesn't
I
change.
get it.
But my exponent is no longer just an x, so we have to take it times the derivative of the inside. So what's the derivative of sine x?
Cosine.
Wait, why would we do that? Like, why are we multiplying by?
It's a chain rule.
Oh, okay.
It's not just e to the x power. So since it's another function in the exponent, we have to do the chain rule, derivative of the inside. And technically, you could do the chain rule if it's just e to the x. You know, it's just e to the x times, what's the derivative of the exponent?
X e to the x.
What's the derivative of
Oh,
X. 1? And so that's why we always said it's just e to the x. So if you do a chain rule unnecessarily, you're just going to be multiplying by 1. It won't change your answer.
Okay, so really just anything that isn't just x.
If it's not a plain x, you have to do chain rule. Alright?
Don't we have to, isn't there more to do there?
Nope. Derivative of e to the power is e to the power.
Oh, okay.
I mean, you could write the cosine in front.
Yeah, I just thought that there was another part.
Okay. So, we have always done the derivatives of e to a power because e's are nice in terms of derivative. If your base is something else, so if it's 2 to the x or 3 to the x or 4 to the x, the derivative is still the number to that power, but it's times the natural log of the base. So for instance, if I said y equals 2 to the x power, the derivative is still 2 to the x, but times the natural log of 2. Yep. No, you'll leave it like this. Really, if you were thinking about e's, it's e to the x. If you do the natural log of e, what is the natural log of e? It comes full circle, yes. So that's why we prefer the e's, because it's simpler. We don't have the other natural log. But we can do the derivative of any exponential. And I could give you the whole proof of this, but I'm assuming you don't really care.
Nope.
You're just going to believe me. You should know this rule.
You know us so well.
So, know the derivative of number to x is that times natural log of the base. So let's try that. We're just going to do a few. Alright. So, derivative of 3 to a power is still 3 to the power
You're funny looking.
That's not very nice.
times
Natural log.
the natural log of the base. But what else do I need?
You gotta bring your exponent down, right?
My exponent was not just a plain x, so chain rule, derivative of the inside. What's the derivative of 4x plus 1? 4. Can I multiply the 4 and my 3?
No.
No, they're not like terms. I mean, you could write like 4 natural log of 3, that's just some number, times 3 to the 4x plus 1, if you chose to. But these are equivalent. You can't do anything here.
It's crazy.
I thought I was missing stuff.
Alright. Let's look at the next one. Give this one a try.